So welcome everyone and thank you for joining us today. My name is Maoz and I will be the moderator for this webinar. Today we have an exciting topic we're going to talk about. Cyber-informed engineering transforms IT and OT convergence in oil and gas operations. So just a couple of notes before we are starting. This webinar is recorded and an email with the link to the recording will be sent out to you in the upcoming days. This webinar is going to be about 45 minutes followed by 15 minutes of Q&As. Please make sure to submit your questions on the chat at any time during the session. We will definitely try to answer all of your questions. Of course, we do have a time limit. Last, if you're interested in learning more about unidirectional solutions specific to your industry and use case, I'll place a link in the chat so you can contact us directly and schedule a call with one of our experts. And that's basically it. Our first panelist is Kevin Ritty, a critical infrastructure technology consultant and the president and founder of Revelation SCS. Turning the stage to you, Kevin.
Thank you, Maz. I appreciate that. I'd like to take a moment to welcome everybody. I'm glad to see that we've got a good group of people that have joined and are looking to explore this interesting topic I think we have today. I'd like to quickly introduce the two other gentlemen with me. Andrew Genter, who is the Vice President of Industrial Security for Waterfall Security. And he is a recognized technology expert in this industry. He is also an author, an accomplished author with 3 texts, and is also a media sensation and with all the podcasts and contributions he makes to our security industry. And I'm also here with Alan Aquatella, who is the segment leader for Pipeline and New Energies Infrastructure with Schneider Electric. And I've had the pleasure of working with Alan for years. He brings decades of knowledge around all the customer problem space, and that's the main issues and expertise that it will help bring, I think, a tangibleness to the topic today. So with that introduction, we'd like to move on to what exactly is our challenge. Okay. I'd like to use the term OT-IT integration, okay? And we're looking at things that today, cybersecurity is moving beyond just data loss, okay? It is now looking, there are physical repercussions and implications. And so we wanted to start looking at that as a problem and give a history and work our way through what some of the challenges the oil and gas industry across all segments is encountering.
Yeah, so let me chime in here. It's traditional to start a briefing on cybersecurity, talking about the challenges, and part of the challenge is the evolving threat environment. This chart is from the last year's threat report from Waterfall and ICS Strive. You can see the URL. Excuse me. You can go there and download your own copy. The threat report does not talk about attacks that stole data, does not talk about attacks that could have caused consequences. The threat report talks about deliberate attacks, not errors and omissions. It talks about deliberate attacks that caused physical consequences, most often production shutdowns, but sometimes equipment damage, and in principle, loss of life, but there was none in this data set. Deliberate attacks, physical consequences in the industries we track, which is manufacturing and heavy industry, critical industrial infrastructures, including all of the various variations of the oil and gas industry in the public record. Okay, this data set includes no private disclosures. You can go into the appendix and click on the link and see for yourself on the front page of the New York Times a description of every one of these attacks that we counted. With those criteria, deliberate attacks, physical consequences, heavy industry, public record. How many attacks were there in 2010? There was one. It was Stuxnet. 2011, there was none. 2012, there was two. We bounced around between 0 and 6 for the entire decade, 2010 through 2019. The problem was seen by laymen as theoretical. Why are we talking about this? There does not seem to be anything happening. And then it changed. 2018, there was one attack. The semiconductor fab went down in Taiwan. 2019, there was 6. 2020, there was 18. The next year, there was 23. The year after, there was 57. What we're seeing this decade is what appears to be exponential growth, roughly doubling every year in terms of attacks with physical consequences. A lot of them are ransomware. Okay. A lot of the ransomware groups are very sophisticated. Some of the ransomware groups are backed by nation states. North Korea backs their criminal ransomware groups in order to produce foreign currency for the sanctioned regime. Other ransomware groups are bluntly so wealthy that they can afford to buy their own nation state grade attack tools. And so the threat environment has changed. It went from a decade where the problem was largely theoretical to this decade where the problem is doubling every year. And the worst of the ransomware, the worst of the attackers out there on the internet are nation state grade. This is the new reality. For a decade, we saw nation states poking at each other with Stuxnet and with Triton. And we thought, yeah, but, would a nation state ever come after me? Yeah, well, today, ransomware groups are trailing nation states by only 3 or 4 years in terms of attack capabilities. What we see the nation states doing to each other today, we should expect ransomware to do to everybody with money within a very small number of years. So that's the reality that we're facing. This is why we're talking about cybersecurity. Next slide, please.
So as I bring back, I like to try to give some context about how we got to where we're at today. When we think about data loss, when we think about cybersecurity, I go back in the industry to the late 80s and have seen a great deal of changes over time in the way companies were perceiving things. In the 90s, we began seeing companies realizing there was data, right? Our networks became more mature, became more interconnected, and all of a sudden this data that had been traditionally inside your SCADA, your control systems, people started looking and say, hey, that would be really cool. Can I get this over here for this report, or can I derive something from it? So all of a sudden in the 90s, it became almost the Wild West, right? Everybody's looking for things. We're looking at ODBC, we're looking at DCOM, we've got spreadsheets, we've got databases, we've got SQL reports, etc. And it was all about just getting access to the data. 9/11 happens and the plug gets pulled again, so to speak. Networks get locked down, the walls go back up, and the protection becomes much more significant. Okay. But post 9/11, data still was desired. So as time and we distanced ourselves from the immediate fear that 9/11 brought to the table, we started looking and saying, okay, how can we securely transfer information out of OT into our commercial applications, our corporate networks? So data availability, still critical, still majorly important, but now security all of a sudden became an issue. And now it's important to say, this is what we still want this information, but we can't be the Wild West anymore. So this is where we started seeing the Purdue model come in, true network segmentation, DMZs introduced, corporate applications, and laid out in very organized, specific ways. Also during this time, there really was no regulatory pressure as it relates to cybersecurity. And this is important because midstream and the oil and gas industry has always had certain regulatory pressures, but they've always been related to safety and operational, not necessarily cyber, right? So we were able to have long-term field devices because everybody acknowledged the high cost of replacement. There were legacy systems and end-of-life OSs, but it was like, as long as it's buried, we're good, okay? And security was subjugated to safe operations. I'm not saying it was ignored, but priority has always been given in this industry to safe operations. And then in 21, we had the Colonial ransomware attack. And this dovetails with what Andrew's talking about, this nation state grade. This is actually was structured by a ransomware as a service group. Okay, this operation. So it's production grade, it's commercial grade ransomware. This resulted in a $17 million at least estimated cost for a 6-day shutdown, right? So we're still seeing those Purdue model, firewall and force segmentation, strong defense in depth. The OT was shut down because of a risk of compromise. Had there been a model that they were able to ensure no backflow in that IT compromise, then would we have had the same pressure? What happens here is we end up seeing the first regulatory level of cybersecurity obligations for oil and gas. Now, this is of course focused on midstream, but when we start looking at it, these are sound practices. Okay, these are standard cybersecurity programs that are used throughout. So it's something that I would not say we'll never see in any of our other segments. Okay. Daniel, I totally agree that it was a true IT attack. And again, it was careful. That's why I make that point that the shutdown was caused because of risk of compromise. The OT system, in all my understandings, was never compromised. Okay. One of the things I like to say is, and this comes, I guess, from my software background, is this idea of personas. And who are the players in driving some of these conversations today? We have SCADA operations, and these are the ones who are the operators, the controllers, the engineers that are focused on operating our assets safe and secure, right? So they're thinking about, when they look at our operations, they see PLCs, pumps, compressors, pipes, ladder logic, programming algorithms, all are related to delivering and managing our assets. Okay, now we're introducing a more and more formal IT/OT type of security collaboration. Again, we're bringing back that tie-in, IT/OT, integration. Now, OT is bringing that unique engineering perspective. IT is bringing in their cybersecurity networking expertise. We're sharing the same technology, okay? But the drive of safety and availability as motivators isn't necessarily where they're thinking. They're more regulatory demands. They see domains, they see firewalls, they see switches, they see segmentation. If I showed a Purdue model, we'd see SCADA operations looking at layer 1, 2, and 3. IT's thinking, well, I've got domains here, I've got firewalls here, switches. They see the same system, but from a different perspective. Our corporate brethren, they're looking at what type of data can I get? How can it be exploited? How can I make money? How can I reduce my environmental exposure? What are my reporting obligations, right? And then we have our risk office. And this is something that more corporations are doing. You see it under either the CISO or the CFO type of office. And these are people that are looking at corporate risk. They're looking now expanding into operational risk. What type of they're interested in avoiding civil and criminal liability. SEC reporting is changing. The impacts are changing. Legal pressures are going to become real. Okay, and these people look at the same operations, and they're looking at financial risk. They look at risk of loss of life. This goes back directly to what Andrew was saying, is attacks are starting to look at not data extrication, but they're looking at, can I harm human beings? I mean, that was Triton, bellwether event. The risk officers are also looking at regulatory pressures and, of course, executive liability. Some of the pressure points that I think we all are feeling, regardless of where we sit in the value chain of our industry. Okay, critical infrastructure, greater scrutiny, DHS, CISA, TSA, European organizations, everybody's starting to get their magnifying glasses out and look at how critical infrastructure and acknowledging its importance and its role. I mean, Colonial, while it was not life and death, arguably we were days away from a managed crisis that we'd have to work through as a country or a nation, okay, on diesel shortages and managing supply chain. Okay, the TSA directive has established formal obligations for us. Ransomware attacks continue to grow, right? They originate, and this is what Daniel pointed out, they originate often in IT because we're so isolated in OT. We have all that defense in depth, but the question is, how sufficient is our isolation, our segmentation, and our incident response? IIoT and cloud-based applications are introducing exceptions to the Purdue model. We're starting to see this need. European Security Organization is floating a adjustment to the Purdue model to directly account for these type of desired communications. We have financial impacts at the TSA compliance, right? Replacing thousands of RTUs and PLCs just to meet the password compliance. Okay, we're looking at secure data transfer to support analytics, historical tracking, cloud apps, business apps. Okay, Andrew explained in detail the idea of APTs, or advanced persistent threats, nation states, criminal organizations. We just had botnets shut down by the DOJ and the FBI, and both for China and Russia recently. Plus now we're getting AI designed malware. No longer do you even need to be an expert. Plus we have the critical dependency that society has on reliable energy for food delivery, air travel, commuting, heating, clothing. Everything in our society is dependent on this. So all of these external pressures are coming to bear, as well as what we're dealing with internally with our IT teams, our OT teams, our engineers, the need for M&A, et cetera. So we've got a lot of things. So I've kind of set this stage from the high level, looking at the objects. Alan's going to kind of start talking and transitioning us through where a little bit more tangible as to what the industry is facing. Alan. Are you muted, Alan?
Yes, Kevin, thank you. I'll try to summarize with this slide where you're coming from, Kevin, and then dive into more of the pipeline industry situation. But when you think about operational security, technology, and the goal of cybersecurity, it's really about managing risk. But a major fundamental difference with, let's say, in the IT world is that in OT, the risk can be substantial from an environmental standpoint, loss of productions, asset, and even life. So the point of collaboration of these two, let's say, disciplines, it's fundamental to achieve the goal of diminishing risk. And the OT has unique different focus where I think you were mentioning, Kevin, safety, it's absolutely paramount, and availability. And for example, when we think about the different types of actually technology and systems and assets that they protect, we're talking about DCS systems that are fault tolerant, safety systems that have to be, in some cases, have triple modular redundancy, SCADA systems that are typically quad redundancy, and these are controlling refinery, process plants, and pipelines that have a very, very long asset life cycles. We regularly get involved sometimes in greenfield projects that, the requirements are, you got to support this, product lines, up to 20 years or more. more tied to the asset life. So it really brings a distinct focus in terms of the OT as compared to IT. But at the end, these teams need to work together and collaborate to really manage cybersecurity in this type of assets. Next slide, please. Moving a little bit more into the pipeline and SCADA world, over the years, obviously, pipelines, they operate distributed assets. So the fundamental technologies are SCADAs, RTUs, flow computers. And over the years, companies have taken advantage of new technologies. They have upgraded the SCADA systems and so forth, but there's still a lot of legacy equipment that it's inherently exposed. And although some of these companies have taken advantage of newer technologies such as wireless, cloud, and edge analytics, this is actually resulting in the increase on the attack surface and making a stronger case from cybersecurity. This is becoming more of a challenge situation, and we'll see it on the next slide, as Kevin was alluding, with TSA. Topics such as the need to have multi-factor authentication in some of these systems that historically they didn't have, or the fact that you need to centralize your role-based access control and your password protections. Next slide, Kevin, please. So given the state of the industry, I mean, Kevin alluded to the ransomware attack that eventually led to the issuance in 2021 of the first TSA directives. We're now in O2 number D, it's the fourth version now, and fundamentally they speak about well, first of all, starting with an assessment, really understanding where we are in your current states, then having an implementation plan touching many things, including network segmentations that we have mentioned. And then having an incident response plans. But these regulatory requirements are putting an additional burden on the industry. They're pushing the industry in the right directions, but it's something that they have to be keeping up and creates an additional challenge.
Let me chime in there if I may, Alan.
Sure.
When I looked at these directives, what struck me was wording in the directives that I had never seen in 62443, that I had never seen in any other cybersecurity directive before. The directive ordered large pipeline operators to, if there is a serious cyber incident on the IT network, to be able to completely physically disconnect the OT network from IT, so that the OT network could continue working at capacity, at necessary capacity, to keep the pipeline operating. That's the first time I'd seen that written down. They said, well, if you're going to do that, you also need to analyze your dependencies, because if your OT network needs services on the IT network to operate, then it does no good to separate them. You're not going to be able to operate the network. You've got to be able to understand those dependencies and have a plan in place to continue operating OT, even if those dependencies have been crippled because they're part of the IT network. It said you've got to do intrusion detection on that IT-OT interface more intensely than anywhere else in your architecture. It said that you're not allowed to have shared trusts across that very important interface. There was a whole bunch of wording in these directives that I'd never seen before that were talking about the importance of the IT-OT interface. Why is the IT-OT interface, why is that network connection so much more important than any other network connection? Well, I track a lot of other standards and best practice guidance. And what I observed sort of as a trend starting to emerge in the last several years is the idea of a consequence boundary. Why is the IT-OT boundary so important? It's because it's the connection between two networks with very different worst case consequences of compromise. What's the worst thing that can happen if every CPU in a refinery starts doing the wrong thing? Well, the worst that could happen is probably, discharges of hot hydrocarbon gases, fires, explosions, loss of life. The worst is really bad. It's physical. It's unacceptable physical consequences. What's the worst that happens on your business network? Well, you have to bring experts in to clean up the mess. It costs you money. It's generally a business consequence as opposed to a physical consequence. And so what I saw for the first time in these standards that struck me was sort of the idea emerging of a consequence boundary. Next slide, please. And this is sort of why I've been following a new initiative from Idaho National Labs being funded by the Department of Energy called Cyber Informed Engineering. This is looking, it's bringing new insights, new ways of looking at the problem, that didn't exist before. Next slide, please. What is cyber informed engineering? Consequence is part of it. One of the first steps in the methodology is figure out what your worst case consequences are. And to do that, we need safety engineers at the table. We need equipment protection engineers at the table. We need we need cyber experts at the table. We need threat experts at the table. None of these people by themselves can do the job. Cyber informed engineering positions the problem, positions the solution to OT security, not, as a bunch of independent domains. It positions it as a coin with two sides. One side is teach engineering teams about cyber threat and about cybersecurity solutions. The other side of the coin is engineering. Use powerful engineering tools to address not just physical risk, but cyber risk as well. Concrete example. If your life depends on a boiler or a catalytic cracker not overpressurizing and blowing up in your face, how would you like to be protected from a cyber attack that overheats the furnace under the cracker? Would you prefer a mechanical valve where if the pressure, the gas pressure in the cracker is too high, it physically forces the valve open against a spring? The hot gases escape into a flare stack. We flare them and nobody dies? Or would you prefer a longer password on the PLC controlling the furnace? In a sense, it's the wrong question. If my life was on the line servicing a catalytic cracker, I would want the mechanical pressure relief valves. I'd want 3 of them, thank you, because these things do wear out, they corrode. I would want the longer password on the PLC. I would want a boatload, an absolute boatload of cybersecurity beside that, because this is my life on the line. And cyber-informed engineering, again, is not, you don't choose one side of the coin or the other. It's the whole coin. We need all of cybersecurity and all of engineering. Here's the thing, though. We've been neglecting the engineering tools. Where is the mechanical pressure relief valve? Where's the mechanical valve in ISO 27001? No mention of it. In the NIST Cybersecurity Framework? No mention of it. Where is it in the industrial 62443 standards? No mention of it. These are all cybersecurity standards. The pressure relief valve, centrifugal governors, electromechanical safeties are engineering tools, and they provide engineering grade protections. The engineering profession uses these tools when public safety is at risk, when worker safety is at risk, when national security is at risk. National security, how can national security be at risk in a cyber attack on a pipeline? Well, what is the legal definition? The legal definition of critical infrastructure. It's critical to the nation. Okay, if we take down critical infrastructure, we put the nation at risk. And so when the engineering profession, when national security is at risk, when public safety is at risk, when worker safety is at risk, the engineering profession prefers to use engineering grade solutions, unhackable, the pressure relief valve behaves deterministically. The failure modes can be modeled mathematically. This is the kind of tool the engineering profession prefers, engineering grade solutions, for the most consequential of circumstances. And again, cyber-informed engineering says use these tools systematically, use them universally in addition to cybersecurity. Next slide, please.
So I'm back to kind of give some thoughts around why is cyber-informed engineering intriguing? Why, and I think Andrew has, and that is what he was just talking about, really, I think, drives home the point of where this approach on, consequence-driven, thinking about cyber from the beginning, okay, is so critical to our industry and the way we think about developing and designing solutions. What I realized as I was kind of researching and reading about this practice that INL has proposed and DOE is pushing, okay, is it was so similar to what we in software do as a secure development lifecycle, right? We capture requirements, we do design, implementation, verification, and testing, deployment, and maintenance. Okay, this circle, this cycle that we live under, okay? And it's bringing that type of maturing to system design and system deployment, and for us to start thinking about engineered solutions in the way we may think about software solutions. And I'm not saying that software's ideal or perfect. It's just, it is a process. This is something that's been engaged in our world for a long time, a number of years now. Okay, so CIE is introducing this to bring IT, OT, corporate experts, risk officers, bringing all those personas into the room. Okay, so we're looking at breaking boundaries, right? We're looking at engineering, like Andrew's saying, they're going to bring a very critical perspective, but it's an incomplete perspective for the whole solution. The same for our IT and security people, right? They're going to bring that network and domain expertise, but it's only part of the picture, very digitally focused, and our engineers are going to be very process, very system focused, right? So we're looking at it as bringing everything in and then saying, okay, let's look at how these pieces and start asking ourselves bigger and broader risk considerations. Andrew's example about a physical relief valve. There was and I've wonder if I bring this up now, just based on even a couple of comments I've seen, is during the colonial, after the colonial thing, the president was in front of Congress of colonial, and he was being asked, why didn't you just run the line manually? And he responded, all those people are dead. So we, in a sense, have to, or don't exist anymore. They're not in our company. They're not available to us. So that expertise, that knowledge has evaporated over time. And so by expanding our pool, expanding our questions, we're going to start encountering a broader perspective of what our system risk is. And we can start looking at that. We can start considering the boundaries and saying, this happens here. What is our implications? Okay, it could be as simple as, what is the implication of a support person coming in with a thumb drive? Okay, a la Stuxnet. I mean, that's how Stuxnet was deployed at the end of the day. And it's really funny is security people will lay thumb drives out and about during pen testing in some cases, and the number of people that pick them up and plug them into a computer is mind-blowing. Okay, even people that should know better still can't overcome that human curiosity. So we're looking at maturing our engineering practice. We're looking at bringing cybersecurity into the question, okay, and asking the risk implications and how could we mitigate physical derivatives or errors or implications, and or mitigating cyber. If it's compromised, is there a way that I have a fallback to continue operating, to be safe, to secure if I don't have that digital component? Okay. And that kind of ties in, right? Everything we do today has a digital component. Your cars do, your devices do, everything we do is now driven by software. Okay. So this is where, to me, just kind of really drove this home to me, the value that we could do on this. So Alan's going to kind of take over from here and start talking a bit more about the industry. Where is it? And some thoughts about maybe how to continue to advance. Alan?
Excellent. Thank you, Kevin. So I would like to, before we map out where the industry is, just to recap on 62443, which is, many of you know, it's a global standard performance and risk base for OT cybersecurity. And one of the key aspects is really to identify the security level that is really needed to reducing risk to an acceptable level. And that's translated in that SL1 through SL4. And as Andrew was alluding, well, before that, the severity is typically considering two aspects: the attackers' competencies, motivations, and capabilities. And from the threat reports and Andrew's comments, you see that those are increasingly sophisticated and more in numbers from either nation states or this ransomware attacks, and then obviously the criticality of the assets and the impact on the incidents. And coming back to oil and gas and the pipeline industry, they are really operating in, as Andrew alluded, not just critical infrastructure, but actually national critical infrastructure. And Andrew, you reminded me of a case. I mean, we operate globally, but our customers in France, the TSO, for example, the pipeline industry is being elevated as national critical infrastructure, just like the nuclear industry. So it is, it is. Let's say with that in mind, that I would like to point now to the right-hand side. If you look at the oil and gas utilities, and where it says renewables, that is where the industry is currently. And again, although the ambition is to be SL3 and ideally SL4, we're really far from that. And then when you think about the roadmap and the phases that these companies need to have in terms of having really mature programs, only 10% in general of the companies are there. Could we go back to the next slide, Kevin? Yeah, I'm not going to go into the details of this, but we really see cybersecurity as a journey, going from your SL2 to your SL3 and SL4, and really the key point here is understanding where you are, at least in the pipeline industry, where you want to go is at least you have your north on your regulatory directives, but this is where you can start using this concept of cyber informed engineering to really support, let's say, your journey. Back to you, Kevin.
Thank you, Alan. So I want to talk about process a little bit. This is starting to lead us towards the transition to some more practical discussions. But this is a process that we need to start thinking about how we start bringing IT and OT in a secure interface and sound integration as we start transferring more and more information and start building more. And I'm going to kind of contradict myself in some ways later on, but the systems are more complex. So we have to figure out how to make this interface and interactions more, simpler in the way we work. So let's talk about the CCE process. I've talked about it as a broad life cycle, but now let's get a little more tangible, right? So we bring our parties together in this consequence prioritization. So we're looking at risk management here. We're introducing a formal process of looking at, this is a scenario, this is the consequence, this is the impact, financial, et cetera, and combine that to create a mathematical value that helps us determine priorities, importance, and what are things that we need to deal with important. And the thing is that it's critical by bringing the parties together. As Andrew said numerous times, expertise relies or exists in different parts of our organizations. Break the boundaries down, pull those experts into a room and talk and get them to put things down and start talking and engaging and get both sides and to be open to that communications. Okay, really think about it. And do you want to even think about expanding that by bringing out in outside cybersecurity experts that can give you a broader perspective on how they might exploit your system or consider pathways into it. Okay, phase two, system to system analysis. When I look at this, and phase three is kind of merging a little bit into a term that we use in software called threat modeling. So here you're looking at all the pathways, how information can move through the system, where are your interdependencies, what are critical processes, how have you structured your boundaries, and if you use the threat modeling software like Microsoft's, you literally can, draw boundaries around certain portions of your system and clearly demark those. So this starts looking at, and everybody can see the diagram and starts analyzing and say, this is a problem because of this. No, hey, that's a really good approach. Or if we used encryption here or TLS here, we could improve this with minimal effort. And we start thinking about it. Consequences is bringing phase ones into that threat discussion and saying, okay, if I come into here, what happens if I compromise, say, the emergency shutdown or the safety system? How do we recover? If we're saying, well, if that goes down, we're done, the plant burns and it's going to be really ugly. Or we say, okay, we need to think about that. That system is compromised, a la Triton. How do we overcome that? If we have to shut it down, what do we do in its place? And you start looking at those type of things. And that introduces us to phase four, right? Mitigations and protections. Now we're getting tangible into the process. We're looking at actual actions. We're going to say, if this happens and this is the consequence that we're preventing, we're going to say all boilers in certain that heat cracking towers will have a backup, a primary and secondary relief valve. Okay, and that goes back into purchasing, it goes back into budgeting and the whole process, and it's this big cycle as you're constantly looking at it because new threats are going to come up. What if a device's password was compromised or nobody set the changed the default password and it was taken over as a botnet? Those all are becoming the questions that we'd answer. So like I said, that's kind of setting the cycle, where are we, where are companies struggling today? But what are some of the options? Not all the answers, but what are some of the things that we can look at in technology or methods that you should consider CIE and securing that boundary? Now, Andrew.
Yeah, so let me jump in there. I talked about consequence boundaries. I talked about the emerging sort of collection of techniques that is starting to be called network engineering. This is chapter 5 in my new book. The book is available for free for people who are interested. We are not able to ship everywhere in the world, but if you go to that URL, you can see where we do ship and hopefully request a free copy. Let's talk network engineering. I talked about, cyber-informed engineering as a coin with two sides. Network engineering, in a sense, is the glue that connects the world of engineering to the world of IT. It's the discipline that sits at the boundary between those two other disciplines. What is it? Well, imagine the refinery example, the catalytic cracker, the overpressure valve. If that valve engages and hot hydrocarbons go up the flare stack, what happens? Well, there's no explosion. Nobody dies. This is all good. And we shut down at least the cracker, sometimes the whole refinery. Why? Because that was a safety incident. That was never supposed to happen. That's a last-ditch protection. All of the other digital safeties failed, caused the overpressure condition. We're going to shut things down until we understand what just happened and until we have, understand how to fix things so that this never happens again. And we take those measures and we fix these things. We don't run when safety is at risk. That's a problem, though, because, in a big refinery, you're producing gasoline and diesel fuel and jet fuel for the nation. And now, we're critical infrastructure. Now the nation is at risk because we can't produce what we need to produce. This was not the goal. What we need is to prevent this outcome in the first place. How do we do that? The only way to do that is to prevent the attack, the cyber attack, getting into the network in the first place. And this is network engineering. It's a collection of techniques. Again, it's not one technique, it's a collection of techniques that I document in chapter 5 that are focused on preventing. They are engineering grade prevention of the propagation, the movement of attacks from IT networks back into OT. Next slide, please. The single most popular technique in network engineering is something called a unidirectional gateway. The NIST 882 standard defines a unidirectional gateway as a combination of hardware and software. The hardware is physically able to move information in only one direction, usually from the OT network into IT. And the software makes copies of servers and emulates devices. Next slide, please. This is what the hardware, one example of what the hardware looks like under the hood. If you look closely at the slide, you'll see a physical divider, a piece of metal down the center. An auditor can run their finger down that divider and verify visually that there is no cross connect. The only cross connect between the left side of the device and the right side is a fiber optic cable. And again, if you look at the hardware, there's a fiber optic laser, a transmitter on the left. There's a fiber optic receiver, a photocell on the right. In the circuit board on the right, there is no laser. With a firewall, if we can go back to the previous slide, with a firewall, if you configure the firewall correctly, then it should not allow attacks from the IT network into OT. With this device, it's deterministic. It's engineering grade unidirectionality. With this device, it does not matter how you configure the device. It's not physically possible to send cyber attack information from the outside of the device to the inside of the device. The hardware cannot, it's not that it will not do that, it cannot do that. The software is, in a sense, where the magic is. If you've never seen this technology before, if you've got an OPC server, a Pi server, a SQL server on the left on the OT network, the software logs into that server, let's say a Pi server, asks the server for everything that's new, everything since the last time we asked a second ago, gets back 5, 10, 30 megabytes of data, pushes the data through the weird one-way hardware, and on the outside, the software in the device logs into an identical server. If it's Pi on the inside, it's Pi on the outside, and updates the server. And now we've synchronized the two servers, just like the software-based Pi to Pi application does. We've synchronized the two servers. Anybody on the enterprise network who needs the data can ask the enterprise Pi server for the data, gets the same answer as the industrial Pi server would have provided without ever sending any message, any information, any attack information potentially back into the OT network that might put the OT network at risk. So again, it does not matter how clever our enemies are across the internet. It does not matter how many nation states have got their intelligence agencies knocking on our IT door. Even if they get into IT, it's not physically possible to pivot an attack from IT through this kind of device or other kinds of network engineering. But this is the most popular kind. It's not possible to pivot an attack through this device into the OT network to put physical operations at risk. So this is a concrete example of the kind of thing that makes sense when we're looking at unacceptable consequences to society or to the workers or to the business as far as that goes. Next slide, please. And the one after that. Thank you.
So now I want to talk about design and operational principles. We've looked at something practical. This is a little philosophical, but I think it's going to dovetail nicely as we kind of work our way through. I use the term current state, future state, brownfield, greenfield. Okay, what I'm looking at is what are we doing today? We typically do our design, we implement a solution or system or a package, okay, and then we put it in a lockbox. Okay, we bury it in defense and depth, and we basically say, yeah, even if something's insecure in there, we've got enough layers or locks around it that it won't be an issue. Okay, so what we're looking at is on the right hand side, this future state where you're looking at design at the beginning, right? Secure by design. So we're bringing in security into the conversation during the design, implementing it in implementation, bringing it to bear so that when we do put it into production, we're not bolting on security. We're not looking at it and saying, okay, I have to rely that all the pieces around me are functioning in order to know that this piece is secure or is able to be resilient, okay, due to an attack or failure situation. Okay, so what are some of the biggest ticket items for thinking about, right? Consequence focused design. Think about what could happen. Engineered controls. What we're saying is it's baked in. You don't have to, you can't always go back and fix what we're doing, but when something new and an opportunity presents itself, either through a revamp, a new deployment, an extension, expansion, start asking these questions in that process, right? Start looking at understanding data flow pathways, design simplification, reduce your attack surface, bring your world under control, bring those surfaces that are exposed to, risk, to attack or present threat vectors, and you're and I'll talk about this in another diagram, so I'll just continue. And then also don't do away with defense in depth. That's all part of a comprehensive security, right? And I also like this highlight that they brought into here, built-in system degradation. This is, okay, I'm in a crisis. What is the least I can do? If I have a compromise in one section, how do I make sure everything else continues to function? So I can control my system degradation as I encounter or have potentially a domino type of effect of a failure situation or a key piece. How do I keep my operation safe and secure and still running? So kind of tying into Andrew, this again, I'm looking at this as contextually, an architectural thought, right? We look at, and you can obviously see the inherent layers that we all work with, but there are a couple of areas, and generally we protect everything with a firewall, right? We have firewalls behind firewalls, behind firewalls, we have layers, domains, segmentation, protocol control, certificates, everything, right? So, but we start looking for opportunities that what could I do to reduce my attack surface? Field devices and configuration managers, right? So if I start looking at these traditional spaces, and I start considering where something like a unidirectional gateway, it may not fit all use cases, but what are we talking about? We're talking about reducing your attack surface, facilitating better incident response, simpler incident response. So instead of a firewall protecting your PI exchange, you leverage a UGW. Your corporate to cloud. People don't realize that the cloud can be compromised. It is nothing more than a server farm sitting in somebody else's infrastructure that we just have an internet connection to. So that's all compromisable. That can all be misconfigured. So all the threats that we talk about are expanded, tenfold, hundredfold when we start exporting our data and information. We have product support. Is there a way to reduce the risk of having somebody foreign or external to my company come inside? What about patching? We have to patch. Is there a way to reduce the exposure of pushing patches into my system? SEM and SOC, how do I start introducing that technology? Is it at the corporate level? Is it at the OT level? As I start bringing new pieces in, IIoT, we have devices and then they're smart and they push data directly to the cloud so that, is there a way to bring something like a UGW, which there is, okay, to control that pathway, preventing another vector into my systems? Okay. So Alan now is going to chat a little bit more about the technology, the practical in the more traditional space and what he's been seeing in the industry.
Yeah. So I think the main message here, Kevin, is we wanted to bring kind of more of a real world example to what you were saying, and the challenges as operators have with these brownfield systems that have been kind of bolt on. And actually, this reflects one of the customers that we have had a refinery, had a terminal not connected, and they needed some data. So this schematic actually reflects a little bit the future state that where they are, but also the challenges that they face. And although we usually produce models and we separate each of the layers, I think this brings Andrew's point of the importance of network engineering as a fundamental discipline in terms of how do we address hardening the systems. And you can see, for example, on the technologies used, the unidirectional gateway on the top right, providing, that fire hose from the OT network back to the IT systems, and without really a possibility for compromise. I think the last comment I wanted to highlight is that layer 2.5 on cybersecurity management. That doesn't exist in all of the plans, but at the end we want to make sure that those processes and those technologies can be more autonomous, and they're less burdensome to the operators. Their business is to operate, but through those type of technologies, your endpoints, your domain controllers, Active Directory, your antivirus, patching services, and so forth, describe on that layer, that adds a fundamental part of security. Next slide, Kevin. I think we're kind of running out of time. Just a reminder again, coming back to the oil and gas industry, and particularly the pipeline. We spoke about the TSA directives. It's a major, push in the industry. Let's go to the last one. And really what we proposed and what we suggest, at Schneider Electric, given that this is a journey, is to really consider, your current states, make your assessments, and, work with partners that have, service, that can provide services associated to the TSA compliance, that have point solutions, but also can sustain, your effort through long term. And then regarding the solutions, again, pointing what Andrew said, network engineering and technologies like unidirectional gateways are a fundamental piece in this puzzle. Back to you, Kevin.
So let's just kind of wrap this up by some key takeaways, some things that we think are important for you to consider or think. This is what we came away as individuals. One, I loved CIE because it ensures the collaboration of IT and OT expertise. It's about introducing your consequences and bringing it into your process. So the mitigations, the responses are built in. So it's a secure by design. It's comprehensive. Andrew?
Yeah, and I just wanted to point out that there are, emerging perspectives. The engineering perspective on public safety is very different from the IT perspective, the enterprise security perspective on public safety. And the engineering team tend to be responsible for public safety. They're looking at the problem differently. They're looking at network engineering as a way to assure public safety. When you design a bridge, the engineering profession, does not hope that we can detect cyber attacks on, I don't know, stabilizers for the bridge, does not hope that we can detect these attacks in time to prevent, I don't know, harmonic frequencies destroying the bridge. The engineering profession does not hope that if we detect an attack in time, we can scramble an incident response team fast enough to prevent an explosion in the refinery. Okay, engineering teams design bridges, they design refineries, the bridges in particular, they design bridges to carry a specified load for a specified number of decades in a specified operating environment with a large margin for error. This is the demand that we're starting to see, the perspective that we're starting to see be applied when there's serious consequences, when public safety, when worker safety, when the what's the right word, the survival of the business is at stake if there is a worst case attack. So unidirectional gateways are deterministic. They are engineering grade prevention of the propagation of cyber attacks. They are, in a sense, the heart of network engineering, not the only technique there, but the most widely used technique, and one that I think we're going to see more widely used in the future.
Yeah, and I think to complement Andrew, what Weinsteiner proposed is, really, you got to look into secure by design, starting actually from the product development, how you develop your software, to to your network, your hardware, this system of system approach you have. They have to be all cyber secure, and you have to be consequence aware. And finally, the concept of the consequence-driven engineering really help reduce those attack surfaces and potentially the incident impact. Back to you, Kevin.
So this wraps us up. I knew we were going to have way too much information as we were getting through this. So we'd like to move as quickly as we can into question and answer. Please enter your questions in the Q&A tab, and I will take a look through, and we'll start pulling some answers out. I'll bring
and if I may interrupt, sorry. For anyone who has to leave the webinar, never fear. We are recording this, and there will be a link sent out afterwards if with all the Q&A in it.
Okay. Here's one. We had a question about, is there an update to the Purdue model that addresses the IT-OT convergence? I can take that, or Andrew, would you?
You go for it, and I'll chime in.
Okay. There is not a formal update that I've seen to the Purdue model. It's not really changed that much. You might see a designation of like layer 3.5 to create a little further granularity. What I have seen, and I encountered when I was doing some research around the Colonial, is there is an agency out of Europe that is proposing some adjustments to the Purdue model to specifically account for this IIoT type of device, where maybe the device communicates directly to a parallel system that doesn't necessarily go directly to SCADA. Maybe it goes directly to a leak detection style system
Exactly.
or an operational optimization system, or it leverages something like a 5G communication pathway and goes completely outside the boundaries. So they're starting to look at that, but I've not seen a formal update that addresses this. This is, I think, kind of a struggle where each company and industry segment's looking at it specifically.
Yeah, let me chime in there. I think the Purdue model is never going to go away. I mean, what is the Purdue model? It's a naming convention. It didn't start as network segmentation. It started as a naming convention so that we could talk about classes of equipment that kind of do the same thing. And it turned out that the criteria that the Purdue University used for arranging those technologies into groups that kind of do the same thing turned out to be the natural way to segment networks. Because how do you segment networks? You segment them by putting together into segments groups of devices that kind of have the same needs, that kind of do the same thing, that kind of have the same consequence. So that the fact that these devices fit together in network segments, I think, is never going to go away. What is changing, what's evolving, is how the networks are connected with each other. And in 62443 terminology, this is not the zones. The zones are the networks. The Purdue model is a zoning standard. The way the networks are connected is conduits in 62443 terminology. And the question is, where are they connected? What kind of conduit, what kind of protection is in place at the conduits? And this is what's being debated. We're seeing more and more connections. We're seeing connections from the very lowest levels of the Purdue model straight out to the internet for cloud systems.
Yes.
And again, that's a consequence boundary. When we have consequence boundaries, we have the potential of attacks pivoting through those boundaries, and that's unacceptable. And this is where network engineering comes in. The more we want to connect things, the more we're going to need network engineering when there are sharp differences in consequence. Alan, did you want to chime in?
No, I think you have been nailing the head. I think that probably from the industry that you see, yes, they use a Purdue model, but you start to see use cases, as Kevin alluded, more in the IoT asset management, where devices have to connect with other systems, not necessarily for process control. So companies are having to coexist in terms of the traditional process control and Purdue model, and this more IoT applications that do have tremendous value from an asset management, sensing more things. And then the other thing is the advancement of some of these devices. I mean, you have sensors that can do control in the field. You can go from a sensor to cloud in some applications. So it's interesting how this will evolve going forward. But again, the principles of the network engineering and the critical boundaries are stand out. Yeah. Back to you.
We have another question. This is going to be directly to a UGW question. So, Andrew, this will be right in your wheelhouse. Specifically, how do you transfer data that requires an acknowledge message back from IT if the data is unidirectional? Do you have special code, new protocols for each needed bidirectional communication, or do you simply make all data unidirectional for security?
So there's no new protocols. It's a lot of people, when they see the device the first time, they say this smells like a unidirectional firewall, and that's the wrong mental model to have. Route packets from one network to another. Fundamentally, this is what they do. Yes, there's a ridiculous amount of security software on top of that routing function that looks at every message and asks the question, is this an attack? Is this message allowed? But if it's not an attack according to the rules, if it's allowed according to the rules, what does the firewall do? That layer of software gives the message to the routing layer, and it routes the packets. The gateways are not routers. They never send network messages from the industrial network out to the IT network. I mean, we talked about, Aviva Pi replication. How do you do that? You send a small question. Please give me all the new data. You get a big answer, 30 megabytes of data. You look at what happens on the IT network. You send a large command. Here's 30 megabytes. Update the Pi server. You get a small answer back. Yep, that's done. Now what? These are completely different conversations. Small question, big answer, big command, small answer. None of these messages make any sense sending them from one network to another. The gateway, the unidirectional gateway is an endpoint of communications on either side. It behaves like a client of Pi on one side and a client of Pi on the other side, not like a router. So it's the wrong mental model to ask. The question doesn't make sense. Can you send acknowledgements through? It's the wrong model. We're not communicating with a protocol all the way through.
Let's see. I'm trying to run through questions.
Yeah. Kevin,
This
let's
is
give it
interesting.
for another last question, and then we can wrap it up.
Okay, last question. Let me try to find one. There is a question. You talked about security by design. How would we deal with all the legacy equipment present in the industry in this context? In the sense, how do we fix things that have existed, be they legacy OS, legacy devices, etc.? Alan?
Sir, can you repeat the question?
Sure. Basically, it's about legacy equipment. A lot of companies are starting to have to swap devices to meet
Yes.
password requirements, things like that. So are some of the issues? Is there a better way? Are there intermediate ways that industry can deal with legacy equipment?
Yes, that's a great point, Kevin. And there's not a straight answer. You have the typical, end of life that due to obsolescent chipset, lack of support from vendors, it can force you, let's say, to upgrade. And really, what we recommend companies is to look. There's been so much advancements in technology to more of this, next generation devices. We see, on the other hand, that some of the other vendors, through software firmware upgrades, are able to add things like, password protection, rollback-based access control that was, let's say, unavailable. But it's really a mixed bag. I mean, we see even, some operators that are taking a high ground and are taking the opportunity of this end of life. And, some other vendors are actually upgrading platforms to say, well, what should be our next generation platforms moving in, and have multi-year programs of rip and replace endpoints. So you see falling then all over the map. But I think at the end, companies that have look at this in a programmatic way, really stay up to code, stay up to the later standards. That's I think the way to go. Yeah, back to you.
If I might jump in on that, a lot of people talk about the greenfield versus brownfield. Where to begin? I submit that consequence is the fundamental difference between oil and gas OT networks and their IT networks. There's a lot of other superficial differences. Things are hard to patch. Things are hard to change passwords on. Things are hard to put antivirus on. If we had a magic wand and we could wave a magic wand and magically upgrade everything to the latest version, upgrade everything to the latest patch level, antivirus everywhere, long passwords everywhere, even if we had that magic wand, bang, it's all completely up to date. It smells greenfield. Two things would happen. One is we would still have to manage the OT network differently than we manage the IT network, because there's truly unacceptable consequences if it's compromised, if it's mismanaged, if it's deliberately mismanaged. And the second thing is, the reason, some of the reason that we have old equipment in our systems is inertia. Most of the reason is change control. Every time we change something, we have to test the crap out of it forever, because every change is a threat. Software is complicated. Most modern software, is too big to prove correct. And so now, we have to test it. It's just managing is expensive. And the moment we wave the magic wand, 10 days later, we've got a brownfield situation again. Brownfield is the nature of the beast. It's never going to go away. We should stop talking about brownfield and just start calling it normal. This is the world. And it's because of consequence. And once we understand that, once we wrap our heads around that, decision making starts getting clearer.
Yes, great point, Andrew.
Okay. There's one other one that I do feel like it may be worth asking. There was a question about working with European countries and specifically in Scandinavian. I didn't know if that was a quick one you could answer, Andrew, or not. I don't know all the
Sure. I mean,
market segments.
I'll answer for Waterfall. We have customers all over the world. We have customers in the Scandinavian countries. When you leave, you're going to get a little questionnaire saying, do you want someone to reach out to you? We're happy to reach out to you. Leave us your contact information and we can introduce you to nearby customers. Alan should weigh in. Does Schneider Electric have any customers in Scandinavia?
One or two.
One or two. Yeah, sorry, go ahead.
No, that's part of the NIST hub. I work with those guys regularly with their group of architects. So just send any request, via Andrew, and we'll connect you with the right team.
That's right, and we work closely with partners like Schneider all the time. So it's not an either or.
Absolutely
we work together to solve problems. And I want to remind people, it looks like we might not have time to answer all of your good questions. We will try and do that by email. And feel free to, like I said, click the button and ask for a follow-up, and we'll get in touch and try and continue the conversation.
Okay.
So as Andrew said,
looking at the time, I think we're well over. So
yeah, we're gonna wrap it up. Yeah, and just like a final words, as Andrew said, we're going to reach out to you guys with many questions. We're going to answer it over email. I really hope you find this webinar informative and super relevant to you. Just point out again to the link that's in the chat in case you guys want to talk with Waterfall's expert or Schneider Electric expert. You can schedule a call with us. And this is for today.
Thank you all.
Thank you.
Thanks everybody for attending.